What's up, everybody? Welcome to another episode of Let's Ask Paul, the podcast where you get to ask me, Paul Abernathy, anything you want about the National Electrical Code and all things electrically related. All you got to do is go to paulabernathy.com, and it's pretty easy. You put your name in, your email address, submit your question, and we'll either answer it in a reply, or if selected, it will be on an upcoming podcast, much like today's podcast. So thanks for joining me again. It's great to have you here. If you've never listened to our podcast before, we have over 1,000 episodes that can be enjoyed from any of your favorite podcast listening platforms, whether it's Google Podcasts, Spreaker Podcasts, Spotify. I listen to most of my stuff from most of the podcasts I listen to, business podcasts. I listen over on Spotify. But, you can even listen on your Alexa device by, there is a actual, you can just ask it to play the Master the NEC podcast and it'll do it for you. But yeah, that's what you do on whether you're Google Podcast, Apple Podcast, whatever your favorite platform is, just go searching for Master the NEC podcast, all separate words. Okay. And, you will find our podcasts. We also have episodes on Let's Ask Paul. And if you want to listen to Let's Ask Paul specifically, then you can also do that from the Let's Ask Paul, from the official website, which is where you go to submit your questions at paulabernathy.com. But the other way you can listen is through our mobile app. So we have a neat feature that you can listen to podcasts there as well. So many ways that you can connect and listen to a podcast, whether you're cruising down the road, you're on a job site or whatnot. And there's so many of them. Again, like I said, it dates back years and most of the information is still relevant. So go check it out. All right, today's episode, going to remind everybody that these are sponsored by Wix and they're also sponsored by Electrical Code Academy Incorporated. That would be a no-brainer, right? Yeah. So if you want some of our cool swag, it helps support the show, go to fasttracksystem.com. That's fasttracksystem.com, fasttracksystem.com. And you will see that we have a link to our store. We have a bunch of new goodies over there. One of the newest things is our voltage drop cards. Not only are we going to give you the formulas for voltage drop, but I'm also going to show you how to calculate the exact K, which you're ultimately going to round anyway to whatever the normal K that we would use, 12.9. That time, you get it? Okay. So anyway, I tell you how to do it, but you're not going to really do it. But it's great to know. So it's just good info to have. So anyway, okay, let's get into today's episode. Somebody has asked me to talk about series circuits and parallel circuits, and are there any things to keep in mind when trying to perform these circuits? Well, many people will say today there's really no need to try to memorize or understand series and parallel circuits. It's just not something that you have to think about all the time, except for, on an exam, it's low-hanging fruit. They're liable to ask you a series circuit. Now, if you're into electronics, this stuff happens all the time for you. But at the end of the day, it's probably not something that you as an electrician run into having to calculate out a series or parallel circuit that often, if ever in your career, right? I don't think in my mind I've ever had to worry about it except for when I was doing things like alarm systems and stuff like that. And I was really sensitive on the equipment and all this kind of stuff. But other than that, you probably don't run into it that often. Now, you're going to be that one guy, okay, that listens to the podcast and says, oh, I disagree. I do it all the time. Okay, whatever. I feel you. Reality is most electricians don't. So let's be real. You don't speak for the majority. You speak for your own minority, right? So for the end of the day, on an exam, though, it is important to make sure that you understand some of the fundamentals that are involved in series and parallel circuit applications. So we're going to kind of go over that, talk about it a little bit, and give some kind of rule of thumbs and things to remember. Now, by no means is there an expectation for somebody to memorize all this stuff? When you're studying for an electrical exam, or you're the teacher or your educator, It's nice to have this thing as a resource, keep it friendly and easy. The Ugly's book is great. I'm using that for an examples today. Ugly book's great. Pick up a copy of that just to have it with you. Works great. But there's by no means do these things you should have to try to commit to memory. Okay, so let's talk a little bit for you're preparing for an exam or you get a question and we're talking about series circuits. Now, at the root of it, what is a series circuit? Well, that's a series circuit where is actually the electrons are flowing in one path, through the circuit. Now, when we say this in theory, we're not talking about alternating current, moving back and forth. We're just talking about the basics of being able to do the calculation and the concept of series that it flows, And the series circuit is a circuit that has only one path through which the electrons may flow, And then that is, again, understanding theory that the electrons aren't really flowing. It's the movement of those electrons that create the reaction and yada, yada, yada. But it's going to help you understand the kind of in your mind thinking of a flow, So a couple of rules that you want to remember about series circuits is that the total current in a series circuit is equal to the current in any other part of the circuit, So, for example, the total current of adding all the current up, if it's 10 amps, then the current is going to be the same at any part of the series circuit. So, total current, or IT, is going to be the same as the current at node 1, or node 2, or node 3, or node 4. At the end of the day, they're all going to be the same. So, if it's 10 amps, then it's 10 amps throughout the series circuit. That does not change, Now, that's the first rule to remember. The total current does what? The total current is equal to the current at any other part in that circuit. So if I'm seeing something in series and it's a 10 amps is the overall load, and they ask me a question about what's the amps at node 1, and it's a series circuit, then you know if it's 10 amps total, then the total is 10 amps at node 1, The next one would be dealing with voltage. So again, a series circuit, And when we say series, we're talking about starting out at the source, going out through the load, through the whole system, all the way back, and then coming back to the source. That's a series circuit, Just one big complete loop, So when it comes to voltage in a series circuit, the voltage is equal to the sum of the voltage across all parts of the circuit, So what does that mean? So the total voltage is equal to whatever the voltage is at node 1, plus the voltage at node 2, plus the voltage is node 3. So one thing to remember about a series circuit is the voltages are additive. So if they give you a question and it gives specific voltage at each node, then the total voltage, if it's 120 volt, it should be additive, So if they give you 2 voltage at 2 points and the third one doesn't have a voltage, then you add up node 1 and node 2, and you subtract that from the 120, which is at the source, and that'll tell you what the value is for the third node when it comes to the voltage. Make sense? They're additive. Next and the last component with this one is the resistance. So the resistance, when it comes to a series circuit, the total resistance is equal to the sum of the resistance of all the parts of the circuit, just like the voltage. So one thing to remember is in a series circuit, current is the same. The voltage and the resistance are additive. It's a summation. So if you can remember that. Series circuit, current remains the same. Voltage and resistance is summation or additive. So when it comes to the resistance, the total resistance is just the resistance at node 1 plus the resistance at node 2 plus the resistance at node 3. Add them all up, then that's your total resistance, Now, it's important to realize that you need to know Ohm's law, and I have a separate podcast that I did just on Ohm's law. So make sure you go check that out. I think that it is Let's Ask Paul, episode 171, I believe. But that is just purely an episode on Ohm's law. Obviously, to be able to get the values here, the amps, the voltage and resistance, you got to know Ohm's law, right? It makes sense that you need to know all of these factors, okay? So if I had to give you an example, and I gave you some loads in a series circuit, okay? And it flows through all these loads, flows through everything, okay? So if we had a resistance, and maybe we had a light, and we have resistance, and we have some other load, and so we'll call it 3 different nodes, okay? 3 nodes on a series circuit, three points where there's going to be a load, okay? Okay, so I'm going to give you some values, and we're trying to find what's the overall voltage, what's the overall current, and what's the overall resistance, right? Makes sense? Okay, so here's what it is at each node. And if you want to take notes, you can take notes. And this is also available in your Ugly. Okay, so I'm not reinventing the wheel here because I wanted to be able to give you a resource to go back to. But many of you don't have the Ugly, so I just want to talk to you. These are examples. So the first load it's 8 volts at that load. There's 0.4 amps of current, and the resistance is 20 ohms. Okay, well, the first one we can answer this entire question when it says, what is the current? Remember what we said in this whole thing? The current in a series is equal to any other part of the circuit. So I can already tell you the current total for this entire circuit is going to be 0.4 amps. Right? Makes sense? That's the total. Again, that's the whole equation there, as we told you that the current is nothing more. It's the same at every node. It's only the voltage and the resistance that become additive. Make sense? Okay, so the first node was 8 volts, 0.4 amps, and 20 ohms. Okay, so we already knocked one question out of the way. We know what the total current is. It's 0.4 amps. That's it. The next thing is the second node, which is 10 volts. And then we know it's 0.4 amps. And then we know it's 25 ohms of resistance. Okay, that's the second node. And then the third node was 6 volts. And then we had, again, amps is 0.4 amps. And then the resistance is 15 ohms. Well, remember, this is easy for us. So the current is exactly the same. And the volts and the resistance are additive. So it's simply 8 at the first node plus 10 volts at the second node plus 6 volts at the third node. That's 24 volts. Easy peasy, right? And then when it comes to the ohms, it's simply 20 ohms at the first one, 25 ohms at the second one, and 15 ohms at the third one. So that is 60 ohms. These are pretty simple if you keep in your mind, right? Just keep thinking in your mind that, again, when I'm dealing with current, all the nodes are the same. It's going to be the same current in a series circuit. But when it comes to the voltage and the resistance, it's additive. Makes sense? Okay. So making that a little harder for the series circuit, and again, this is about as hard as they're going to get, folks, on an exam. Trust me, this is going to be it. So now I've got 4 different loads, 4 different resistive loads, and I'm going to give you the values, but I'm going to tell you stuff that's missing. And you're going to say, what? How the hell do I solve what's missing? Well, this is when you got to know Ohm's law. And this is why you need to listen to the other podcast when it comes to Ohm's law, because we're going to work this one out. But I will bring in those formulas while we try to solve this. So relax. We'll do it all together. And this is going to be difficult for you to listen to and follow along. So just listen. I will do my best to elaborate on each node. Okay? I will do my best to do that. Okay. So the very first load, all we have in our equation is the resistance, 72 ohms. That's all it gives us. It doesn't give me the voltage, and it doesn't give me the current. Okay? But watch. watch how we're going to do this, because the other loads give you other varying values, and this is how they do it on exams, okay? So that's fine. We know the resistance of R1 is 72 ohms. Perfect. Now, the resistance at the second load gives us 12 volts, okay? But then it doesn't give us the current, same as it didn't give us the current on the first one. And then it doesn't give me the resistance on this one. That's okay. That's okay. As long as now I've got the volts. So I got 12 volts. Okay, so I got 12 volts so far. And I've got 72 ohms in the first resistance ohms. And then in the second one, I got nothing. It doesn't tell me. That's fine. That's fine. So at the third one, now we've got nothing for the voltage. Okay, that's fine. But we have the current. The current is 0.5 amperes at this node, third node. Great. Remember what we said about current? Current does not change. It stays the same. So we have that variable that we can use. And remember now that we have the current, and then in all these other ones, we have the resistance, we can solve for the other things that we don't know. Remember, if you listen to my Ohm's Law podcast, this is where people will see a question like this and freak out. It's all right here. You just have to take your time. Okay, so now this third node also lists it at 48 ohms of resistance for this third node. Okay, so we're going to write that down, 48 ohms. So the first resistive node was 72. The third one was 48. We didn't give us anything for the second one. And now we move on to the fourth one. And the fourth one gives me the voltage, which is 48 volts. Okay, but it doesn't give me any current, and it doesn't give me any resistance. But that's okay, right? Because we know that the current stays the same at every location. So it's 0.5 for that. So we could plug that in on all of these. And that shows us that on all of these loads, we now have at least two variables that we can use to solve the other portions of the loads. Pretty cool, huh? I mean, it's how it works. Okay, so we can plug all this stuff in. So let's take a summary of what we've got. Okay, so I've got the first load. We'll call it the node number 1, and it has no voltage, no resistance. Excuse me, it has no voltage, no current, but it has a resistance of 72 ohms. Okay, so let's work this one first. So what we do is we know that the current stays the same. So we've got, at this first one, we've got 72 ohms, and we've got a 0.5 or 0.5 of amps. So we know we're trying to solve for what? We want to solve for the voltage, correct? Sweet. So what do we do? So if you remember back in my other episode, what formula are we going to use if we have the resistance and we have the amps? So when it comes to volts, we have the amps and we have the resistance. So it's basically, to solve for volts, it's the amps times the volts. All right, so let's do it. So I'm at my calculator here. So I've got the amps, 0.5 times 72, which is the ohms. And that gives me what? That gives me a value of 36 volts. So that's the volt. So at the very first node, I've got 36 volts. I've got 0.5 amps, which again was the same as all of them. And then the resistance was 72 ohms. Now we've already done number 1. That's it. Now we'll do the whole circuits total after we do each node. Okay. So let's move on to the second node. So the second node, we had 12 volts, but we didn't have the current and we didn't have the resistance. Well, now it's easy, right? Because we know what the current is. It's consistent at all points at 0.5, and that was given to us in the node 3, right? So what do? All right, so we have volts, and we have the amps, which is 0.5. So now we're solving for the resistance. So we got 12 volts, and we got 0.5 amps. We go back and look at our Ohm's law wheel and say, okay, what are we trying to solve for? We're trying to solve for the resistance in ohms. Well, if we know the voltage and we know the amps, then we look at the formula that's best for us. And so again, it's simply volts divided by amps. Okay, so let's do that. Let's see here. So it's volts, 0.5 divided by, let's see. No, it's a volts, excuse me. Volts would be, it's 12 volts divided by the amps, which is 0.5. And that's going to give me 24. So we're looking at, all right, so we're solving for this one. So let's see here. The resistance here. Let's see, which one do we doing here? Oh, we're solving for resistance. So yeah, so we do our volts. We go back 12 divided by the amps, and we said it was 0.5. And it's 24. Perfect. So at this point, we know that this one is 12 volts. We know that it is 0.05 amps. And we know that the resistance for this one is going to be 24 ohms. Boom, that's number 2. And at the end, you remember how we add things up? Okay, you get it. So that's number 2. All right, so the third one, we weren't given the voltage, but we were given the amps and we were given the resistance. Oh, this is easy. So we're solving for E. We're trying to find out what the volts are. But since we have the amps and we have the resistance, then it's pretty easy, right? We do the amps times the resistance. So let's just do that on a calculator. So our amps is 0.5 times the resistance, and it gave it to us at 48 ohms, and that is 24. So our volts for that node is 24 volts. So node 3 is 24 volts. The amps is 0.5 amps, and the resistance, which was given to us, was 48 ohms of resistance, and that's number 3. And then the last node, number 4, remember, it was 48 volts for the voltage, but it didn't give us the amps or the resistance. But we know what the amps are because that is constant through all of the nodes. That is 0.5. So we can work this one out. So in this one, we know that we have the 48 volts and we know what the amps are. So let's do node number 4. So it's 48 volts. The amps are 0.5 amps, and we're only solving for the resistance. Well, if we were solving for the resistance and we have the voltage and we have the amps, then it's pretty straightforward, right? The voltage divided by the amps. So let's do that. So the voltage is, let's see here, it's 48 volts divided by the amps, 0.5. And that gives me a total of 96 ohms. See how that works? So it's 48 volts. It is 0.5 amps. And then it's 96 ohms. And that's node number 4. Okay, so now we have all of our nodes. Node number 1, it was 36 volts. It was 0.5 amps. And it was 72 ohms. Our node number 2 was 12 volts, 0.5 amps. And it was 24 ohms. And in node 3, which they didn't give us the voltage, but we calculated at 24 volts. Remember, the amps stayed the same, 0.5. And then it gave us the ohms, which was 48 ohms. And then node number 4, which gave us the voltage, but it did not give us the amps or the resistance. But we know that the amps is easy because it's 0.5 for all of them. So the amps is 0.5. And then the resistance, we calculated out, and that gave us 96 ohms. So what do you do at the end of the day? All right, well, easy. The total current is what? 0.5. Remember, that stayed the same. When it comes to the voltage, it's a summation. So you add them all up. So node number 1 was 36 volts. So 36 plus node number 2 was 12 volts. Plus node number 3 was 24 volts. Plus node number 4 was 48 volts. That equals 120 volts. So this is a 120 volt circuit. Okay. And so we solved that. The current, again, is 0.5 for all of them. And then lastly was the resistance. And what did you do? What did we say you do for resistance? It's a summation when it comes to series. So I'm just going to add them up. So node 1, 72 ohms of resistance. Node 2 was 24 ohms of resistance. Node 3 was 48 ohms of resistance. And node 4 was 96 ohms of resistance. So the overall resistance in the entire circuit was 240 ohms of resistance. That was the total. Make sense? So easiest thing to remember, again, when it comes to series is the current is the same no matter what node of resistance you're at. The current doesn't change. This is a series circuit. However, the voltage and the resistance total is based on a summation, and you have to use the Ohm's law to order to solve each load, and then it's at the end, it's a matter of just adding those up. So that's why it's so important that you, before you jump into something like a series circuit, it may seem simple. It's just a simple series circuit. But a lot of this is based on what they give you. And so as long as they give you some values that you can start doing the equations, you got to know how to do Ohm's law to be able to get those values in order to solve your series circuit. And so if you haven't listened to our podcast on this entitled Ohm's Law Basics, I believe it was episode 171 in the Let's Ask Paul series, make sure you go listen to that before you do this one. But again, if you've already listened to this one and I'm just telling you that, then it's a little too late, isn't it? So now jump back and go listen to the Ohm's Law one. You'll get a better understanding. But that's the basics of series circuits, okay? All right, that's all we're going to do for this episode, just talking series. Yes, I am the only guy in the world that can drag a series circuit explanation out to 30 minutes, but it is what it is. If you don't like it, don't listen. Till next time, folks, stay safe. God bless, and stay tuned for another episode where I will talk about the basics of a parallel circuit and understanding how you calculate those out. But before you move on to that one, make sure you go listen to the Ohm's Law episode. Again, episode 171, I believe. Don't hold that to me. All right, till next time, stay safe. God bless.